Hi students, how are you? I hope that you are doing fine. We have been doing the MCQs of chapter 2 polynomials. We have done around 28 MCQs till now. We will be doing the remaining MCQs today. I have already uploaded many videos of class 10 mathematics and the links are already available in the description. If you are watching this video for the first time, please subscribe to it and share it amongst your friends. So let us do the 29th question. The maximum number of zeros that a polynomial of degree 4 can have. So it is very obvious because the degree is 4, therefore the number of zeros will be, the maximum number of zeros will be 4. So option D, 4 is the correct answer. Let us do question number 30. The graph of the polynomial p of x is equal to 3x minus 2 is a straight line which intersects the x-axis at exactly one point, namely 4 options are given. So let us solve this. P of x is 3x minus 2. Therefore, 3x is equal to 2, x is equal to 2 by 3. So we got the value of x 2 by 3. What will be the value of y? Y will be 0. So the point will be 2 by 3 and 0. Now we know that 3x minus 2, it is a straight line. So it will cut the x-axis at 2 by 3 and 0. Question number 31. In the figure given below, the number of zeros of the polynomial f of x is. So it is very clearly evident that that graph is intersecting the x-axis only at 3 points. Therefore, it will have 3 zeros. Now let us do question number 32. If alpha, beta are the zeros of the polynomial s squared minus 16, then alpha into beta and alpha plus beta is. Now we got this equation s squared minus 16. So that we can write s squared minus 0x minus 16. So if alpha and beta are the roots, sum of the roots alpha plus beta is minus b by a. So minus b is 0. So it will be 0. Alpha into beta is c by a. What is c? That is minus 16. A is 1. So alpha into beta is 0. Now alpha into beta and alpha plus beta. Therefore this alpha into alpha plus beta is 0. This is minus 16 into 0. So the answer will be 0. That means if alpha plus beta is 0, then the answer will be 0. Question number 33. The graph of the polynomial a squared plus bx plus c is an upward parabola if conditions of a is given. So you can see it on the right side. If the parabola opens upward, then a will be always greater than 0. If the parabola opens downward, then a will be less than 0. Please remember these two things. The question number 34, it will be a downward parabola if a is less than 0. Question number 35. If alpha and 1 by alpha are the zeros of the polynomial a squared plus bx plus c, then the value of c. Now alpha and 1 by alpha, they are the zeros of this polynomial. So if you take alpha into beta, the alpha into beta is c by a. So alpha, here beta is 1 by alpha, 1 by alpha is equal to c by a. So this will be 1 because alpha and alpha will get cancelled. So 1 is equal to c by a. Therefore c is equal to 1 into a, that is a. So c will be a. Question number 36. Zeros of the polynomial s squared minus 11 are. So in this polynomial, so s squared will be 11, x will be plus or minus square root of 11. This option is not there in A, B, C or D. Therefore, none of the above will be the correct choice. Now question number 37. A quadratic polynomial whose sum of the zeros is 2 and the product is 1 is given by. So we know the general formula, s squared minus sum of the zeros into x plus product of the zeros. So s squared minus sum is 2x plus 1. So the answer is s squared minus 2x plus 1. Question number 38. If one of the zeros of the quadratic polynomial a squared plus bx plus c is 0, then the other zero is. Now a squared plus bx plus c, one of the zeros is 0. So let b is equal to 0. So alpha plus 0, that is alpha plus beta, sum of the zeros will be minus b by a. Therefore alpha will be minus b by a. Question number 39. The sum and the product of the zeros of the polynomial 6s squared minus 5 respectively are. 4 options are given to us. In this question, 6s squared minus 5 can be written as 6s squared minus 0x minus 5 because the second term is not there. So we can write minus 0x. Let us divide this equation by 6. So s squared by 0 by 6x minus 5 by x. So here the second term will be 0 because 0 by 6 is 0, and here it will be minus 5 by 6. We know that s squared minus sum of the zeros into x plus product of the zeros. Therefore the answer will be 0 and minus 5 by x. Let us do question number 40. If one zero of 3s squared minus 8s plus 2k plus 1 is 7 times the other, find k. Now in this question, 3s squared minus 8s plus 2k plus 1. So it is in the form a squared plus bx plus c. So what is given to us? One root. Let beta be 7 times the other, 7 alpha. So alpha plus beta will be 8 by 3 and alpha into beta is 2k plus 1 divided by 3. Now let us see, in this case alpha plus what is beta? Beta is 7 alpha is equal to 8 by 3. So 8 alpha is 8 by 3. Therefore alpha is 8 by 3 divided by 8, that is 1 by 3. If alpha is 1 by 3, beta will be 7 times of alpha. So it will be 7 by 3. Now let us do alpha into beta. Alpha into beta, that is alpha into beta is 2k plus 1 by 3. So what is alpha into beta? Alpha is 1 by 3 into 7 by 3 is equal to 2k plus 1 divided by 3. So this will be 7 by 9 is equal to 2k plus 1 divided by 3. So it is 21 by 9 is equal to 2k plus 1. So it is 7 by 3 is equal to 2k plus 1. Therefore 2k is equal to 7 by 3 minus 1, that is 7 minus 3 divided by 3, that is 4 by 3. 2k is 4 by 3, therefore k is equal to 4 by 3 into 2, that is 2 by 3. So the value of k is 2 by 3. Let us do question number 41. Sum of the squares of the zeros of the polynomial p of x is equal to s squared plus 7x minus k is 25. Find k. Please remember, we have done this type of question earlier. Here the question is sum of the squares of the zeros. Please don't take it as alpha plus beta. What is given is alpha squared plus beta squared is 25. This is given to us. So we have to find out the value of k. So from this equation we can find out alpha plus beta is minus b by a and alpha into beta is c by a. Now we know that alpha plus beta the whole square is equal to alpha square plus beta square plus 2 alpha beta. It is in the form a plus b the whole square, a square plus b square plus 2ab. So what is alpha plus beta? That is minus 7 the whole square is equal to alpha square plus beta square is 25 plus 2 into alpha into beta is minus k. So it is 49 is equal to 25 plus minus 2k. Therefore this will be 24 is equal to minus 2k 12 is equal to minus k. So the value of k is equal to minus 12. Now let us do question number 43. If alpha and s are the zeros of p of x is equal to 2s squared plus 5x plus k such that alpha square plus s square plus ax is equal to 21 by 4, then k equal to. Since we are using alpha and beta, so let us, instead of s, let us do beta. Now here this is the equation which is given to us. So alpha plus beta, that is the sum of the roots is minus 5 by 2 and product of the root is c by a, that is k by 2. Now we know that alpha plus beta the whole square is equal to alpha square plus beta square plus 2 into alpha beta. 2 into alpha beta. Now look at this equation and this equation. This is given to us and this we know it. Now here it is 2 alpha beta. What is there? There is only 1 alpha beta. That means if we subtract 1 alpha beta, we will get alpha beta. So if we are subtracting alpha beta here, we have to subtract it here also. Why are we subtracting alpha into beta? So that we get alpha beta on the right side, so that this equation will be the same. So alpha plus beta the whole square minus alpha beta is alpha square plus beta square plus 2 alpha beta minus alpha beta. So this complete thing will become alpha beta. So it will be alpha square plus beta square plus alpha beta. So what is the value of this? That is 21 by 4. So this is 21 by 4. Now let us see alpha beta the whole square is minus 5 by 2 the whole square minus alpha into beta is k by 2. So this is 25 by 4 minus k by 2 is equal to 21 by 4. So if you multiply this into 2, so that the denominator will be 2. So we will be having 25 by 4 minus 2k by 4 is equal to 21 by 4. The complete denominator is 4, so we can omit that. That is 25 minus 2k is 21. Therefore 2k is equal to 25 minus 21, that is 4 is equal to 2k and k is equal to 2. Question number 44. If alpha and beta are the zeros of s squared plus px plus q, then a polynomial having zeros 1 by alpha and 1 by beta is. So we have been given s squared plus px plus q. So sum of the root alpha plus beta is minus b by a, that is minus p. Let it be equation number 1. Alpha into beta is c by a, c by 1, that is 2. Now we have to find out the polynomial which is having 1 by alpha and 1 by beta as their roots. So we know the general equation s squared minus sum of the roots plus into x plus product of the root. This is our general equation. So s squared minus sum 1 by alpha plus 1 by beta into x plus product 1 by alpha into 1 by beta. So it is s squared minus, so we can take the LCM alpha into beta. In the numerator we will get alpha plus beta into x into alpha into beta. Now s squared minus, what is alpha plus beta is minus p, and what is alpha into beta is q into x plus what is alpha 1 by q. So it will be s squared plus minus of minus, it will be plus p by qx plus 1 by q. So we have s squared plus p by qx plus 1 by q. So let us multiply it with q, that is q s squared plus p x plus 1. So the general equation will be k into q s squared plus p x plus 1. Let us do question number 45. The graph of a polynomial is shown. Find the polynomial. Now you can see it on the graph. This graph is cutting the x-axis at minus 2, 0 and 3. So if it is cutting at these 3 points, the zeros are obviously minus 2, 0 and 3. So the zeros are minus 2, 0 and 3. Therefore the equation, that is s plus 2 into x minus 0 into x minus 3. So x minus 0 is x, so x into x plus 2 into x minus 3. So here it will be s squared minus 3x plus 2x minus 6. So it will be x into s squared minus x minus 6. So it will be s cube minus s squared minus 6x. So our answer is s cube minus s squared minus 6x. Question number 46. If 2 is a 0 of p of x is equal to s squared plus 3x plus k, find the value of k. Now 2 is a 0 of this equation. So if we put 2 square plus 3 into 2 plus k, it will be 0. So 4 plus 6 plus k is equal to 0. 10 plus k is equal to 0. Therefore k is equal to minus 10. Let us do question number 47. The zeros of the quadratic polynomial s squared plus 1750x plus 1,75,000 are. 4 options are given. Now in this case, look at here. Let us take it a normal thing. S squared plus 5x plus 6. This is a normal polynomial. So we know that it can be split as x plus 3 into x plus 2. So the roots will be x is equal to minus 3 or x is equal to minus 2. So whenever all the terms are positive, both the roots will be negative, because x here you can see it, x is equal to minus 3 and x is equal to minus 2. Whenever the roots are negative, the complete term, if both of them are negative, this will be positive. Now let us do question number 48. If the zeros of the quadratic polynomial s squared plus a plus 1 into x plus b are 2 and minus 3, then now in this question, what is alpha plus beta? Alpha plus beta is minus b by a, that is minus of a plus 1. What is alpha into beta? That is 2 plus minus 3. So minus a plus 1 is equal to minus 1. Minus and minus will get cancelled. A plus 1 will be 1. Therefore a is equal to 1 minus 1, 0. What is alpha into beta? Sum of the roots, that is b by a. Here it is b by 1. So alpha into beta, that is 2 into minus 3. 2 into minus 3, that is minus 6. So the answers are 0 and minus 6. Now let us do question number 49. Sum and the product of the zeros of the polynomial s squared plus 7x plus 10. So we know that the sum of the zeros, that is alpha plus beta, is minus b by a, that is minus 7. Alpha into beta is c by a, that is 10. So the sum will be minus 7 and the product will be 10. So let us do question number 50. If x is equal to 2 and x is equal to 3 are zeros of the quadratic polynomial s squared plus ax plus b, the values of a and b respectively are. Now in this case we have to find out the values of a and b. What are given is x is equal to 2 and x is equal to 3. So these are the things which is given to us. So alpha plus beta, that is minus b by a, that is minus a. So what is alpha? Alpha is 2, and what is beta is 3. So is equal to a, 5 is equal to minus a, therefore a is equal to minus 5. What is alpha into beta? Product of the root is c by a, here it is b. So what is alpha is 2, what is beta is 3, that is b is equal to 6. So we got the answer minus 5 and 6. With this we have completed 50 MCQs of polynomial. I am sure that you understood the concept of polynomials. If you can do these 50 MCQs, I am sure that you will get 100% marks in polynomials. I have already uploaded many videos and the links are given in the description. Please see it and share it amongst your friends. Wish you all the best.